Hello, everyone. Okay, today we're going to be going through the classifying chemical reactions lab. All right, so it's a five-part lab. The first part is actually burning a piece of magnesium in the flame of a Bunsen burner with crucible tongs. So, first thing you're going to I want to do is you are going to want to take your observations of the magnesium metal. So there it is right there. Let's see if I can get it focused on there. No, not going to focus. So it is a rather shiny metal, hard. It bends pretty easily. Okay. Here we have our Bunsen burner flame. Now, when you burn it, you can see on the flame, there's usually a inner cone with a light blue flame. That will be the hottest part, so we're going to want to get the top of that cone when we burn this. Keeping in mind this is a combustion reaction, so when you're recording your reactants, okay, it is not only the magnesium that is reacting here. A combustion reaction is also oxygen reacting with something, right? It's the oxidization of things. So you're actually taking magnesium and you are reacting it with oxygen to get a reaction. So here's the first reaction we're going to observe. So we're going to put that in there. There it goes. That light is very bright. You don't actually want to look directly at it. When you're all done, there is, I'm just going to turn this off. So what you're left with is this nice white ash. Can't get it to focus. Turn it down here. It'll focus here. So you're left with this nice white ash. You want to take some observations on that. Here is our previous tray that has a bunch of the ash in it. You can see it's not very solid. It crumbles. It's kind of a grayish color. So there's the end of that reaction. Break it up into a powder. Got a couple other pieces of magnesium in there. But there it is. I wonder if I can get a better image of that. So there's your ash. So that is the product that you're going to take observations of. Okay. So our second reaction, we're going to put that stuff aside. Our second reaction that we're going to be looking at is hydrogen peroxide. Okay, so here is our hydrogen peroxide. It is a nice thin, kind of a bit of a glare on there, but it is a nice thin liquid, very much like water. It'll form these bubbles pretty quickly because of the decomposition of hydrogen peroxide. So there is your hydrogen peroxide. You really can't tell the difference between it and water. It's pretty thin, it's clear, doesn't really have much smell, no smell at all really. The other thing we're going to be using here is manganese dioxide. So that is this. I'll get a picture on this here. So there is our manganese dioxide. It's kind of a really dark gray powder. So that's our manganese dioxide. So it's just a really dark gray powder. That is what we're actually going to be mixing here with hydrogen peroxide. So when we do this, what we're going to do is we're actually going to mix them. We're going to trap any gases produced in there with our thumb, and we'll see what it is using a burning splint test. So dump that in there. And it's hard to see, but it is bubbling quite a bit. There it is, bubbling. We're going to trap gases in there. And relight my Bunsen burner here. What else? So we're not burning the bookshelf there. Okay. There we go. Okay. So there's our Bunsen burner. There's our test tube with hopefully trapped gas. We then need a burning splint. So what we're going to do is we're actually going to introduce a glowing splint into this. Okay. So what that means is we're going to set this thing on fire, wait for it to get to the glowing stage, and then blow it out. And there. Ooh. So there it is glowing. What we want to do now is we want to open this up and introduce that in. You'll see it relights. We can do that again if you really want. See, it relights. One more time. You know what? Let's just do it one more time for fun. So as it gets closer to those bubbles, we are relighting the splint. You can see no flame. Put it in. Oh, there's even a little pop that goes with it. And it relights. So that is your burning splint test. What that indicates is that this gas that we are producing as it bubbles is actually oxygen, because with our glowing splint, everything that we have here is ready for combustion. Okay, you've got the wood, you've got the fuel, you've got the heat. The only thing that's missing from this reaction is enough oxygen to actually let it catch on fire. And by bringing it in there, look at that, we can still do it. You can get it to burn. Okay, so that is the glowing splint test. Set that aside. So I just want to note for this reaction, okay, for this reaction with the manganese dioxide and hydrogen peroxide, the manganese dioxide is not actually taking place in this reaction. It is just a catalyst for the main reaction. What you're actually seeing here is the decomposition of hydrogen peroxide into water and oxygen gas. Okay, so that's what you're actually seeing. Those bubbles is the decomposition of the hydrogen peroxide, and it's basically kicking off an oxygen because it's H2O2. Hydrogen peroxide is kicking off an oxygen to become H2O, and that extra oxygen is combining with an extra oxygen from another hydrogen peroxide to form oxygen gas, which is why our glowing splint reignites when you introduce it to that gas. Our third reaction that we have here is going to be a reaction with mossy zinc. So here you can see our mossy zinc is kind of a dull gray metal. There we go. There's a good picture of it. Dull gray metal. Kind of boring to look at. I wonder if I can actually turn these off. There, that's less glare. We got a dull gray metal there. And then we are going to actually get, here our 1 molar hydrochloric acid. Okay. So we got our metal in the test tube. We are going to introduce some hydrochloric acid, and we are going to trap any produced gases the same as before. Okay. There it is. We are going to now introduce 1 and 2. And sure, that'll be about 3. I'm going to do 1 more just for good measure. There we go. Okay, now we're going to want to close that up. And you'll notice some bubbling happening there. All right, get it to focus. There we go. Lots of little bubbling going on. So while I let that reaction go for a little bit, I would also just like to note we should also have taken some observations on our hydrochloric acid. So hydrochloric acid looks like this. I'm hoping you guys have seen it before. You should be pretty familiar with what it looks like. It is very thin, just like a basically looks like water. Can't really tell the difference between it and water. Thin, liquid, room temperature, yada yada yada, all that stuff. On your observation table, you should have that written down. So we let that go for a while. I'm going to need a burning splint for this. I'm going to relight my lovely Bunsen burner here. There she is. Okay. I need to find my splint again. Here we go. So what we're going to do, we're going to check what gas this is. So for this, we're going to use a burning splint. We get our fire. We introduce it. You got to listen for this one, so I'm going to try to bring it over close to the computer. But here we go. Ready? 3, 2, 1. So there you've got a nice little pop. So what that actually tells us about this, usually you can do one of two tests. Usually either do the burning splint test or the glowing splint test. The glowing splint test usually indicates oxygen when it reignites, like we just saw with the hydrogen peroxide and magnesium dioxide. Burning splint indicates when you hear that pop, that is an explosive gas. In this case, since we have hydrogen and zinc, or sorry, hydrochloric acid and zinc, that is hydrogen gas. That indicates the presence of hydrogen gas. So perhaps there might be enough built up again that I might be able to do this test one more time for you. So I'm going to do it one more time. Listen close. You might hear that nice little pop. Here we go. Here we go. 3, 2, 1. Oof. So that is your burning splint test. Flames, we don't need it anymore. And we're going to set that aside. Actually, not yet. We're going to dump that out first and check out. So there is, you remember our previous zinc and what it looked like. So what we now have is take your observations, is this lovely zinc right here. It was the one we were just working with. It is no longer that nice dull gray zinc that we saw before. It has gone kind of a black color. I would love to say the shininess is something, but that's just water. We've lost some of that dull gray color. It is now turned to this black, gross color. It is still hard. You should be taking observations on this as well, okay? So that is the zinc. Last we have copper, not last actually, fourth, we have copper chloride and magnesium. So this reaction actually takes a while. So what I'm going to do, where did I set that now? I had it somewhere. Here we go. So here we have our magnesium in a, what's the word I'm looking for, in a test tube, okay? Tip this up here. We have that magnesium in a test tube. And then here we have our copper chloride solution. So you take observations on that. Ignore the little bits of powder on the bottom. That is just undissolved copper 2 chloride because this has been sitting out for a while. It's been evaporating. So we're going to try to avoid getting too much of that powder in here. But we're going to put that into here and see the reaction that takes place. So I'm going to leave it there. You can kind of see, let's see if I can get that focused. Whoop, bubbling up. Come on, focus. There we go. So you can see it kind of bubbles. That's why it's floating actually. Shake it, it'll go down. You can see it leaves a couple of floaties. There it is there. Starts to go darker. I'm going to set that aside for about 5 minutes while I do the other one, and we'll come back to this one. Okay. So the last one that we're going to do before we come back to that one is silver nitrate and sodium chloride. So I prepared this here. This here is a, what's the word I'm looking for? This is the salt solution, sodium chloride. Okay. So you can take observations on that. Why is it not focusing? Come on, focus. There we go. It is pretty much indistinguishable from water. Okay. And this is our silver chloride, or silver nitrate solution. Okay. It is also pretty indistinguishable from water. It does have a slight gray color to it, but it's very slight. It's thin, not a whole lot going on there. Okay. Now the fun part is when we mix them. So here you've got this. I'm going to do this test tube. So here you've got our solution. When you mix the two, I can get it to focus before I mix the two. There we go. When you mix them, there we go. So it goes kind of cloudy. You can't really see. It gets a bit of white. Turns kind of a whitish. I don't know if there's any other color in there. I'm colorblind, makes this really difficult. But there might be a little. It might have just a slight yellowish tone to it, kind of a gross color. But for the most part, it looks a bit like milk. It's pretty thin like water. That is that reaction. Okay, I'm gonna pause the video and we'll check out the other one in about 5 minutes. Okay, and we're back to check out the results of the copper 2 chloride and magnesium reaction. So here it is. You can see a lot of that blue color has disappeared. It's still bubbling a little bit because there's still a reaction going on there. It's really hard to see because it doesn't focus super great there. Come on, focus. But the magnesium has a bunch of these little kind of dark bits on it. You can see it's turned darker. There's a bit of a sediment forming in here. See if we can get that to focus. There we go. You can see there's some sediment bubbling. There's the magnesium. So take your observations on this, and then I am actually going to dump out the liquid, and we can check out what that magnesium looks like inside. Okay, so here we are to check out our magnesium that was in the copper 2 chloride solution. So let's see if I can get that centered there. Focused. Focus. So this is the one right there. That is our magnesium that was in the copper solution. You can see it now actually looks a little bit coppery. So what you're seeing there is, of course, the copper is going through a single displacement reaction with the magnesium. The magnesium is coming out into solution. The copper is being deposited on there as a solid. So you are getting a nice coppery color to that magnesium. And that is the reaction. And I do believe that is everything. So now what you can do on your worksheets here, okay, that is the entire procedure. You should have an observation table where you're going to have observations of the reactants, observations of the reaction and the products, and you are going to note the clues to a chemical reaction. So there should be a fifth column there that is the clues to a chemical reaction. So remember, there are 5 of them. You should note for each reaction which ones indicate a chemical reaction. Remember that you usually want at least 2 of them to guarantee that it is a chemical reaction. Okay, and then there is the question part of the sheet. It looks like this. So what you can do here, you can fill out. Each one asks you for the reaction that is occurring. It wants you to balance it, identify the type of reaction, and the general equation for that type of reaction. After you finish that, there is a discussion here where you are going to define what a catalyst is. You are going to identify the part of the lab that you think involves the catalyst and explain why you think that. Spoiler, I might have already told you in the video. And you're going to answer question number 3, and you're going to come up with a conclusion. All right? Other than that, once you've done that, you can submit it. Make sure that it gets handed in to me because I can't give you marks for stuff that's not submitted. And I will see you guys later.